So I will start my class today. So topic today is taxonomic treatment of allopatric speciation. With this I will share my screen. So the question is taxonomic treatment of allopatric speciation. So what you must learn first is what is allopatric speciation. First, what is a species? Basically, as from a layman's point of view, how do you define a species? A species, according to Ernst Mayr, is a group of reproductively isolated individuals. So, the distinction that this is one species and that is another species comes from the question of reproductive isolation. So, as you know, a cat and a dog, they can never reproduce and produce a hybrid. So, cat is a different species and dog is a different species. So, this according to Mayr is how you distinguish two species. Now, how does two species form? They were actually, they came from common ancestors, and how this species came. So, the question on this actually comes from the certain ways by which speciation takes place. There are many ways of speciation. Among them, one is allopatric speciation. Allopatric speciation is nothing but geographical speciation. So, reproductive isolation is gradually acquired in spatially isolated population. So, you have in one landmass, you have a whole population of, say, a particular species living. Now suddenly a mountain or a sea or something, a geographical barrier comes in between. Now this geographical barrier, it will isolate these two species. So one species on one side of the barrier is unable to mate with another species on another side of the barrier. So when this takes place, then they become reproductively isolated. That is, they are geographically isolated. They are unable. Now days and years and ages, they pass and pass and pass and pass, and gradually on other side of the barrier they start developing. There is no mating between these two groups, so there is no gene flow from one group to the other group, and so they start to develop certain differences on the genetic level. They are accumulated over generations, and natural selection and other evolutionary processes take place, and over certain then suddenly after some time, when the geographical barrier is removed, you will find that this first species has become geographically isolated with the second group on the other side of the barrier. So the two species, they become two species from one species. So, so they are spatially isolated. So the traditional allopatric speciation is also known as dichopatric speciation. This is it means a reasonably large distributional area is divided by a newly arising barrier. That may be geographical, geological, vegetational. Suddenly there is a huge forest comes in between this population, and this population, they cannot meet with each other. So let us see what this dichopatric or traditional allopatric speciation, how it takes place. So this is one whole population in one area at time t1. Then gradually a barrier is trying to form over here. The populations are trying to become separate. Still there is a connection in between. Then a barrier takes place at time t3. So the d1 and d2, they become separated. Gradually time t4, time passes. Then a different species 1 and different species 2, two different species have formed, and now they have a region of overlap, but still they don't mate with each other. They have become two different species. This type of speciation is known as dichopatric speciation. Then we have another speciation known as peripatric speciation, and it occurs by primary isolation. Here a new population is founded outside the continuous species range. A continuous species range, this is a continuous species range, this whole region. So the species is distributed uniformly, the population of that species is distributed uniformly in this whole area. This is a continuous range, but this then becomes discontinuous when a barrier comes up. So outside the is founded outside the continuous range by a single colonist. It can be a fertilized female or a small founder group, and remains isolated long enough to acquire the genetic basis for reproductive isolation. Now let us see how this happens. So this whole thing which you can see here, this is one whole continuous species population P. From there, maybe one little bit pinches off as population A is pinched off outside, a fertilized female or a new founder comes from somewhere else, or comes from here, it comes out. Another is pinched out as C, another is pinched out as B, and another is pinched out as D. Now time passes. C becomes extinct. B also becomes extinct. A and T are still there. Again time passes. A and D, they take a different characteristics. Therefore their color changes. They have become some other changes are taking place. And A, T, this becomes extinct. A starts to become extinct, and only D remains, and D becomes a separate population. And now when D and the original population are they have got a region of overlap, they don't meet. So this population P and this D, they have become different species. So this is peripatric. Peripatric is something is pinched out from here and it becomes isolated, a small colony, and over generation this becomes different, and when you bring them back, they don't mate with each other again. So these are the two types of allopatric speciation which you face. And now we come to a taxon. What is how do you in your actual part, what is taxonomic treatment? So taxonomic treatment, whenever the taxonomic encounters two taxonomically distinct allopatric population, a decision must be made whether to consider them species or subspecies. So you find two population, one population in Africa and one population in say a population of horse-looking species, a population of horse-looking animals in Africa and horse-looking animals in America. Now the question of the taxonomists, they face this problem whether to say that they are allopatrically they are separated, that is they are geographically separated, one in one continent, another in another continent, and they have got a huge Pacific Ocean in between, Atlantic Ocean in between them. And so now the question of a taxonomist is, how do I whether I say that these two horses belong to the same species, or whether they belong to different species, or if they are subspecies, that is they are the same species, but among the species they are even very close species, but they are subspecies. For example, we are Homo sapiens sapiens. Our subspecies is the second sapiens. Like that you have several. Columba livia domestica, pigeon. Columba livia is the pigeon species. Livia is the species name, and subspecies is domestica. So there are even wild pigeons. They are not domestica, but they are Columba livia. They can mate with each other. Columba livia domestica and Columba livia in the wild, they can mate with each other. But there are some differences they have cropped. So do we say that the horses are the same species or subspecies? If a pigeon, for example, domestic pigeon in the house and in the cities you see, and you see in the forest a pigeon in the forest. They are the subspecies. You know, they are subspecies. So the question, so these allopatric separated populations, whether they are, so this is the question. So how do taxonomists solve these problems? So there are different types of evidences are considered. First is typological species concept evidence. They consider degree of differences per se to constitute sufficient reasons for species recognition. So basically they look at morphological differences, how they look different, morphological character. By looking at the face or the body features, they say, okay, they look similar, so they are the same species. They look different, but they are the different. But this is not a good way of differentiating a different species. Several species of Drosophila, the small fruit fly, they look absolutely the same. Drosophila simulans and Drosophila melanogaster, they look absolutely basically you cannot distinguish them just by common observation. You need to look at it very finely. But they are different species. They are sibling species, closely related species, but they are different species. They normally, under natural conditions, they don't mate with each other. They have got different courtship patterns and different types of dances. So, this particular typology, only on the basis of morphological evidences, you can't say that since they are looking, both of them look like a horse. The features are like a horse. You cannot say that whether they are the same species, or whether it is Equus calibus America or Equus calibus Africa. You really don't know whether they are subspecies, or whether one is Equus or one is Equus calibus. Whatever. You really don't know according to the species. So this is not actually taken into. Some people use still. This is a way of say differentiating them, okay, that they are species or subspecies, but this is not very popular. So adherent of the biological species concept, they look for evidence or potential interbreeding. So people who believe on the biological species concept, that is reproductive, whether they can mate with each other. As you can very well know that a person population living in America can very well mate with a person living in Asia, and they can have children. It is not that they are different species, they are the same species. And in fact, people, you may even like people, you can get even sexually attracted by people in America, and people in America can get sexually attracted with people in India. That is the same thing. So you know that they are not different species. Under natural conditions, if you keep, people from America and people from India, they are mixed, they will mate with each other and they'll start having children. And so they are not different species. So still, even they are geographically isolated, but they belong to the same species. This is very clear. Both are Homo sapiens sapiens. Maybe they look different. They are even not subspecies. Maybe the race is different. Skin color or the race may be different. That is even going further down. But there is no problem in having children. So this is how. So they look for mating among, but this is not possible always. It is this is absolutely this is very difficult to do it, because always how do you mate? How do you? It is not technically, ethically, under several possibilities, very difficult to measure. Okay, mate and see if you have children, then you are the same species. Well, you can't say that. You can't always do that. Okay, bring an elephant from Asia to an elephant from Africa, and then make them mate with each other and say, okay, they are the same species or not. Well, that is a very tough thing. You can do it for small flies, fruit flies or small animals, which are very easy with plants and all. You can mate them. And then you can see they belong to the same species or not. But for larger animals, and then there are ethical issues. You just simply can't pick a human and pick another human from another continent and say, okay, mate, and then you have, you are having children, so then fine, you are the same species. Well, that is a very impractical way of dealing with experiments. So there are several solutions. So wherever possible, So several solutions and views exist. Some taxonomists, they insist that all morphologically distinct isolated population be treated as full species until it is proved that they are different subspecies. So if they look different, like a chimpanzee and a human, they look different morphologically. So keep them as separate species. Chimpanzee, troglodytes, and humans, Homo sapiens, they are different species. Keep them as different species until they are proved that they are subspecies. Suddenly you see a chimpanzee falls in love with a human, they marry and they have children, then you can consider revising the problem. Well, this is, I'm talking in a funny term, but actually this is how the concept, just to get your concept clear. This solution is of course impractical, because it is impossible in most of these cases to obtain a clear-cut proof one way or the other. This solution overlooks the fact that it is just as serious as an error to call a population a species when it is really a subspecies. So, a person in Africa, a dark skin colored person, his hair is also different, and a person in India whose hair is different and skin maybe is not that dark, they look more or less a lot different. Just on that basis, you can call them a different species. Well, that's not true, because you can mate with an African, you can still have children. So the African is also of the same species. So all the case is very impractical and it's not correct. Just because, but morphologically they are not that similar. Our skin color is totally different. Our facial features, the size of lips, our tongue, the way we talk, it is different. Maybe there is a race is different, but even it's not among subspecies. Say you are in a place full of Africans, you can fall in love with an African girl, you can fall in love with an African man, and that's quite possible. In fact, African men are most sought targets in Europe, among European girls. I mean, they are basically attracted very much physically towards them. And this is quite a racial term, but I'm not talking in terms of racism, because I respect all human kind, irrespective of their caste, creed, color, religion, whatever, as same. I respect people whether they have got a good heart or a bad heart. So this is how I make a distinction. I distinguish people according whether they will be able to do the job for me or not, whether they have got a good I distinguish students whether they are able to, they are good quality students or bad quality students. I don't distinguish students on the basis whether they are from Africa or whether from America, whether they are Muslim, Hindu or Christian. I don't distinguish students. I distinguish students whether they are obedient, they are good students, whether in the future they will be able to contribute to the society or not. Those who are not able to do contribute, they are poor students. Let them be in the higher strata of the society or not. So, but this is how this is a distinguish, because they belong to the same species. But if suddenly I won't take a monkey in my class, a real monkey in my class, and say that this monkey is my student. No, my student is a Homo sapiens sapiens sapiens. So this is how basically a different species and a different subspecies you can distinguish. So a second solution is to treat all populations that are not connected by intergradation as a full species. Now this is also a very bad way of speaking, that all population where there is no mixing, you consider them as different species. And the reverse of this conclusion is drawn, that populations that are not connected by intergradation are conspecific. So population, so you are living in a jungle, you live with monkeys and apes who resemble you. You consider them also as the same species? Well, no. So people who are geographically separated, they are separate species. So the opposite of it, those who are not geographically separated, they belong to the same species, conspecific. Well, that is also not true. So there are a lot of conflicts. On one hand, you are saying that look at their morphology. If their morphology is same, well, they are the same species. And then you say that okay, and if they are geographically isolated and morphology are different, they are different. That is also has a problem. The second solution is that okay, morphologically similar, they are different population, there is no connection, they are separate species. That is also wrong. You don't treat them like that. So both of these have got problems. They have got positive ways by which you can do. You have got negative ways. For in the example, the African rhino and the Indian rhino, they are different. They have got morphological difference. But will you consider them as different species, or will you consider them as subspecies? Because the African rhino has got two horns. The Indian rhino has one horn, or the other way around. I'm confused in this part. But whether you consider them to be single species, or whether you consider them to be two different species, but different subspecies. Therefore, they are different subspecies, so their horns are different. So how do you do the naming? So this, however, this is all in conflicts. And also another thing, there are certain intrinsic mechanisms of reproductive isolation. Intrinsic mechanism of reproductive isolation. There is another type of speciation. It is known as sympatric speciation. That is, a different species is formed sympatrically. That is, in the same location, but because of other factors, behavioral factors. For example, in our culture, marriages are taking place according how if the girl is fair skinned or not, only then the boy will marry, because fair skinned girl is under demand, high demand. Again, as this I am talking in terms of not in terms of racism. So this is a social stigma. They are fair skinned, so more sexually attractive, and therefore that's the person will marry. So we are living in the same place. You have fair skinned and dark skinned. So all the boys are looking for fair skinned girls, and they are marrying them, and then all the children are also becoming fair skinned, and suddenly the days pass, and then suddenly you see that the dark skinned population and the fair skinned population, they become two different species. Quite possible in the same location. Then there is a preference also. Some people prefer to work in the morning, some people prefer to work in the night. So people who are working in the morning, they are sleeping in the night. People who are working in the night, they are sleeping in the morning. So suddenly it happens that those who are sleeping in the morning, they are unable to mate with people who are working in the morning, and people who are sleeping in the night, they are unable to mate with people who are working in the night. So suddenly they becomes they are living in the same place, but they become reproductively isolated, and ages and generations pass, and they suddenly, people who are working in the morning and people who are working in the night, they become different species. This is in a very layman and very simple and very wrong way to give you the right opinion, right idea. A wrong way to say to give you the right idea. गलती से सही चीज बताना, जिसे कहते हैं गलत चीज बोल के सही चीज समझाना, because evolution works in a much more intricate process. So, but geographical isolation, it is not inbuilt, intrinsic. Like for example, working in the morning, that is inbuilt in you. You feel much better working in the morning. Some people feel much better when they are studying in the night. Right? Some people feel better studying in the morning. So that is intrinsic, that is inside you. Nobody is telling you to do it. You feel better. Okay, सवेरे पढ़ने से अच्छा लगता है, रात को पढ़ने से अच्छा नहीं लगता है. It's something like that. How you go. So accordingly, so it's not intrinsic. So the opposite extreme, considering all related allopatric forms to be conspecific, is also wrong. So geographically, so to consider geographically separated individuals, they look same as same species, is also wrong, and they are not separated, they are together but they look same, considering them to be also the same species, is also wrong. So both ways this is not working. So the next solution is use of experimental systematics. So wherever possible, try to mate. First, if it's morphologically clear, fine. So if it's morphologically similar, it's fine. But then you have to cross individuals of population whose status is in doubt. When there is a doubt, but humans it's very difficult and it's not needed also. Specifically in cases of certain duck species and certain flies and insects, this in plants, these whenever doubt, then mate. But then this is you are bound for misinterpretation, because certain species of bed bugs, different species, they mate and they have fertile offspring. Lions and tigers, they are different. One is Panthera leo, one is Panthera tigris. Both of them, if you mate them, you have Ligon, Litigon, Tigon. You have hybrids, fertile hybrids being formed. Misleading. You have to be very careful when you are using experimental systematics, trying to breed them. Species such as lion and tiger often hybridize. So you must never misinterpret. You have to be very careful with your experiments. Then there are experiments known as double choice experiments, where females are allowed to select a male of their own population or a male of the population to be tested. Females are taken because in most of the species, females are the choosing partner. Females choose whether I want to mate this with this male or not. So it is always the male trying to play the guitar and presenting the female with a flower and saying "Mujhse shadi karoge" or something like this. It is always the male saying. It's rarely you find a female asking this, because among humans it is the male which is the species which proposes. It is proposes, but it's the female who selects. The male doesn't select. I mean, of course, socially you can force the selection to take place. You can force the woman in the marriage, but if you don't allow them, actually it is the female who chooses which male I want to stay with. The male will choose many. There is a system of animal behavior. You can find polyandry, then polyandry or polygyny. There are different ways. Many mates, some single mate. But it's normally the female which chooses the male, and it's the same in the in species of Drosophila and on the most species. It is the female which chooses the male most of the time. But there are differences. So normally, so in your same population, you place the female and you place a male of the same population. They will mate among flies. Then you go to another population, pick up a male fly and then put it with the fly of this female, and if they mate and have fertile offspring, then you can say that the other population belongs to the same species. This is known as double choice experiment. This way also you can give a taxonomic treatment. Then there are differences in molecular characteristics have to change. The enzyme sequence, the gene sequence, they are also taken into count whether they belong to the same species. In Paramecium, 13 syntypes are present. They were at one time they were considered to be separate species, but later it was found that there was different syntypes, syngens. They are syngens. They don't mate with each other, but morphologically they look the same. So they are known as syngens. Are males and females? You don't consider, they look morphologically different, but you don't consider them different species, because they mate with each other. Two males, they cannot mate with each other to have offsprings, but still you consider them same species. So there are always pros and cons coming. But how do you deal? So experimental system, first look at morphology. If morphology doesn't work, then try for experimental systematics, that is try mating them if it's possible. That's the best way. Otherwise, then look for other characteristics like ecological characteristics. Those who prefer to stay in the mountains, or some prefer to stay in the trees, some prefer to stay in the ground. So these there are differences by which you can differentiate them. So when direct proof is unavailable, it becomes necessary to decide the status of isolated population by means of inference. This is what I was saying, by means of inference. You look at, there are certain yardsticks which you have to measure. Three morphological yardstick, mapkati, are taken when you have to infer, okay, indirectly you try to find out whether they are the same species or not. So degree of difference between sympatric species. So sympatric speciation is the evolution of a new species from a surviving ancestor species while both continue to inhabit the same geographical region. So from one species, another species is formed, one whole big circle. In that big circle, you have one big circle. From in this whole circle, a new species is forming from over here. A new species is, small pinch of population is forming. So you have to see how much difference is between the sympatric species and the other species, between this species and this species. What is the difference? How much morphological difference? Because in sometimes this difference, it can be very great, as in the case of birds of paradise, or as in the case of Drosophila melanogaster and Drosophila simulans, who are sibling species, it is very less. So you have to make a yardstick, মাপকাঠি বানাতে হবে এটার জন্য, যে কতটা আমরা ভাগ, এই এতটা ডিফারেন্স হলে আলাদা স্পিসিস, এতটা সিমিলারিটি হলে সেম স্পিসিস। দেন difference between intergrading subspecies. So amount of morphological difference between most divergent subspecies in the same genus. So in Drosophila ananasi and Drosophila melanogaster, they look, the maximum amount of difference is there. They are different species, but there are maximum, you have to, among the subspecies you must find maximum difference. Okay, till this much amount of difference I will take. After that, this is going to be a new species. You have to make this. And degree of differences between hybridizing population. Lion and tiger, you have got a hybridized population. You must see how much different the lion and tiger are from the original population. The hybrid of the lion and tiger are from the original population. Then you can see, consider whether they are different species or not. So after all these things, closest relationship and allopatry. It is preferable to treat allopatric populations of doubtful rank as subspecies. If you are in doubt, consider them as subspecies of allopatric, where if they are geographically separated. If you are in doubt, consider them as subspecies. Bas, mamla khatam. You are in doubt whether horse in America and horse in Africa, consider them as subspecies. They are the same species but different subspecies. Till you find out later by experiments that they belong to the same species or not. So this is the end of my class today. So I stop sharing, and now let me take the attendance. 16 students have come. Aditi De, BK Yadav, Chandni Shah, Donna Irani, Imran Wasim, Keshav Sharma, Kushal Mukherjee, Madhurima Goswami, Moumita Bishwas, Rishabh Kumar Rao, Saria Armin, Shreya Singh, Shobhan Shaw, Shubham Maji. Okay. Anybody has got any questions? No questions? Then I will end my class today. Thank you for attending class. Thank you very much. হ্যাঁ বলো। হ্যাঁ পাচ্ছি। হুম। একটা জেনাসের অনেক স্পিসিস হতে পারে। They can be several species. Drosophila melanogaster is a species, Drosophila ananasi is a species, Drosophila willistoni is a species, Drosophila simulans is a species. অনেক স্পিসিস হতে পারে। আবার একটা স্পিসিসেরও অনেক সাবস্পিসিস হতে পারে। হুম। হ্যাঁ ইন্দ্রাণী দিনতানি, ওটা বলেছি ওটা পড়তে পড়তে এরকম এসছে। তুমি ইরানি নও তো, তুমি তো ইন্ডিয়ান। ঠিক আছে, ঠিক আছে রাখছি তাহলে। ঠিক আছে,
ওকে স্যার, থ্যাংক ইউ।
ইউ আর ওয়েলকাম ওয়েলকাম।